Good morning class and welcome to another lecture in sustainable energy technology. We are continuing our discussion on energy storage technology. In the previous class we discussed pumped hydro storage, which is a form of mechanical energy storage system. Today we will discuss compressed air energy storage system, which is another form of mechanical energy storage system. The name is compressed air energy storage system, CAES, compressed air energy storage system. So typically these energy storage systems are paired with gas turbine technologies. So like natural gas turbines, these are used in conjunction with natural gas turbine technologies. So how it works, let us look at a schematic of a typical natural gas power plant. Okay. So here air is coming into the power plant. And here we have a compressor. So the compressor is compressing this air, and compressed air is coming out of the compressor and is being transmitted into the combustion chamber. Combustion chamber. Okay. In this combustion chamber, the fuel, which is usually methane or natural gas, is coming into the combustion chamber, mixing with the compressed air and is burning, and the hot pressurized combustion gases are going out of the system. So here we have compressed air line, and this is compressed hot combustion gases. This is going out of the system and is going into your gas turbine. And this pressurized hot gases are being expanded and cooled in the gas turbine, and the energy associated with the pressurized hot combustion gases is transferred into the shaft energy of the gas turbine, which is rotating the shaft, and hence you are getting work output, which is going into your generator to produce electricity. And the expanded and cooled combustion gases are coming out of the system. Expanded and cooled burned gas. Okay. Now this gas turbine is generating the energy that is going into the generator, but part of this energy is also being used to compress the air. So the compressor and the gas turbine work on a common shaft, and part of the rotational energy of the shaft is being absorbed by the compressor to compress the air in the first place. Okay. So typically then air compressors are highly energy intensive and 30 to 40% of the energy generated in the gas turbine is consumed by the compressor. Okay. So a significant sink of energy is the air compressor. Alright. Now typically gas turbines are built so that it can work at a constant RPM to maximize the efficiency. However, as we discussed before, there can be demand supply mismatch. There can be periods of high supply and low demand when the gas turbine is generating more work that is required to be absorbed by the grid, and there can be periods of low supply and high demand when the gas turbine is not producing sufficient quantity of electricity that is required by the grid. So in this context, what is done is a compressed air energy storage system. So what we are doing then is, part of, if demand is low and there is a gas turbine has excess capacity, then the excess capacity is used primarily to compress a lot of air and store it at a certain location. Instead of transmitting that excess energy to the grid, you are actually running the compressor more to get more compressed air out of the system, and you are storing that compressed air in a certain place. Then when the demand is high, then what we do, we are injecting this compressed air back into the gas turbine system so that you are getting more shaft work out of the gas turbine during that period to cater to the excess demand. Okay. So how does this work? We will just show it. Typically, this compressed air facility is located underground in some sort of an underground cavern complex. So let's just look at that first, a schematic. So the pressurized air is stored in this underground cavern. Okay, the bottom section of this cavern is actually connected with some sort of local water system like a lake or a reservoir or a river, so that the bottom section is flooded with water. Okay. So we will discuss how this thing works. First, we will see the input and the output lines. So let's put the compressor. Here we have the gas turbine. Here we have the combustion chamber. This is your compressor, this is your turbine, this is your combustor. Air is entering from outside, air is being sucked into the compressor, and this compressed air is coming back out and going into the combustion chamber. In periods of low demand, we are rerouting part of this air and putting it into the underground cavern system. Okay. So compressed air is being compressed, and part of this compressed air is being rerouted into the underground cavern system where it is stored under pressurized condition. Okay. And when demand is high, part of this pressurized air is bled into the combustion chamber, and you are getting the fuel, methane fuel is coming. Okay, so this is methane, this is compressed air. And this is hot pressurized burned gas. Okay, and this is going into your generator, which is generating electricity. Okay, and this is the exhaust. Okay, so these sections are basically controlled by valves. This kind of valves are there. Okay. So basically, when you have periods of low demand, part of the compressed air is not sent into the combustion chamber, and that air is transmitted into the underground cavern, which is where it is stored. And in periods of high demand, this excess air is coming back into the combustion. You are putting in more methane. You are burning a lot more of the fuel using this excess air, and that is helping to run the turbine faster and generating more electricity. Okay. Now this water or the water system helps to keep the pressure of this air at a constant level. So as the amount of air increases, the water is pushed back out of the system and is going into the water system here. Okay. So that's how the pressure is being kept at a constant value in this location. And when air is being taken out of the system, amount of air is decreasing, then what will happen? Typically the pressure will decrease, correct? But here what happens, the water level increases to keep that space, to occupy that empty space taken out due to the air, and the pressure is being held constant. So the water helps to keep pressure constant. Okay. And this is a water connected to some overground reservoir. So there is a flow of water from the underground cavern to the reservoir. Okay. So this is the overall system of a compressed air energy storage facility. So let's just look into this in words. So in CAES, compressed air energy storage system, during times of low energy demand, the gas turbine is run just to run the compressor with most of the compressed air being routed to the storage unit. Okay. Then during times of high demand, compressed air from the storage unit is delivered back to the combustor and hence energy required to drive the compressor unit is reduced, because you are basically not using compressed air from the compressor system, but a lot of the air is coming from the storage reservoir, so you don't have to compress all that air at the same time. Increasing the energy transmitted to the grid. Okay. So now what is the energy storage unit? Natural salt caverns and hard rock caverns in the underground provide good places to store large amounts of compressed air as they have lower leakage and can withstand high pressures. They also have good thermal insulation so that heat generated during the compression process is not lost. Okay. So natural salt caverns and hard rock caverns in the underground are good places to store large amounts of compressed air because the space is large. They also have lower leakage problems and can withstand the high pressures associated with the compressed air systems. They also have good thermal insulation because the rocks are not very conducting. So the heat generated during the compression process, so usually compressed air comes out hot because a lot of heat is also generated during the compression stage. So that heat is not lost and that heat can be reused in the combustor system to help in the energy efficiency. Constant pressure is maintained by displacement of water that usually exists in the cavern. When pressurized air is added, water is displaced to an above ground reservoir, lake, river, etc. When air is taken out, the water flows back in and hence keeps the air pressure constant. Okay. So that's the compressed air energy storage in short. Okay. So you have an underground cavern system connected with a water system which is helping to keep the pressure constant. It has a good space, good insulation, good leak proofing, and this helps to store the excess compressed air in times of low demand, which can be bled back to the gas turbine in terms of high demand to generate extra power. So what are some of the advantages and disadvantages of a compressed air facility? So it's good with natural gas power plants. So the entire utilization is related to how a natural gas power plant operates. Okay. can have relatively high energy storage capacity. So when you have large underground caverns, and you can put them, and you could put large quantities of pressurized air in it, so the energy storage capacity is also relatively large. Now these two are the good things. Okay, some of the disadvantages is that the capital and maintenance costs are significantly higher than pumped hydro storage, for example. So capital and maintenance costs are significantly higher than pumped hydro, as creation and maintenance of underground pipe systems are required. Okay. Then a second problem is substantial energy losses with round trip efficiency of less than 50%, similar to pumped hydro systems. Okay. There are losses associated with compression, associated with transmission of air into the cavern, then moving the air back out of the cavern. So all of this has significant round trip efficiency losses. Location is restricted to where natural underground cavern systems could be found. So locations is a far more difficult challenge, because you need a place where you do have such underground cavern systems, because actually excavating a cavern like this will make the cost prohibitively higher. So this compressed air energy storage systems are very location specific, and only relatively few locations can be used and be suitable for such systems to be installed. Okay, so that's the basic advantages and disadvantages of a compressed air energy storage system. So in the next class, we will discuss the last of the mechanical energy storage systems, which is the flywheel based energy storage system. Okay, and thank you for listening, and we will see you in the next class. So thank you.